For over 100 years, countless hours have been spent removing set screw-mounted bearings from shafts, causing extended downtime, shaft damage, and a lot of frustration. The burr created to lock the bearing to the shaft becomes a big problem when removing a mounted bearing. The burr creates an interference which catches on the inner ring bore, making it very difficult to remove the bearing. As the bearing is pulled off the shaft, it drags, causing damage to the shaft, requiring time to properly clean and prepare the shaft for the new bearing installation, or oftentimes requires a new shaft. What if a better solution existed to remove a bearing from a shaft? What if you reduced your total downtime? What if you can reduce shafting replacement costs? Many methods exist to remove a bearing from a shaft. We will walk through some of the common methods, and we'll show you a new solution to make bearing removal easier. The recommended method, but not often used removal method, requires a hammer and drift. The set screw burrs are pounded down to eliminate the interference between the shaft and inner ring. The first step is removing the set screws. The burr created from the set screw is visible in the set screw hole. This method takes time and patience, as the burrs must be pounded down enough to allow the bearing to slide off the shaft. After a period of time, the efforts to pound down the burr may be fruitless, and the bearing must be beaten off the shaft with the hammer and drift from the back, if space is available. You can see that the remaining burr in the set screw hole is causing the interference, making removal difficult. This method will only work if there is space available behind the bearing. The mechanic needs to be careful not to impact the shaft, causing additional shaft damage. Depending on how much the burr was pounded down, the damage to the shaft can be significant enough to require a new shaft. If space exists at the end of the shaft and a bearing puller is available, the bearing puller can be used to remove the bearing from the shaft. The first step requires loosening or removing the set screws. You could then pound down the burr to help reduce shaft damage. Then, attach the bearing puller securely around the bearing and position at the end of the shaft. Using a wrench, tighten the nut on the puller, which will pull the bearing off the shaft. Pulling the bearing off the shaft with a puller may cause scratches or gouges on the shaft. The damage to the shaft can be significant enough to require a new shaft. Many users will reach for a grinder, torch, or hammer to remove the bearings, which, beyond safety concerns, can cause the damage to the shaft or surrounding equipment. Note: destructive methods of bearing removal pose a strong risk to personal and surrounding area safety, and as such are not recommended removal methods. A hand grinder is sometimes used to grind the cast iron housing, and then the bearing or other means may be used to remove the bearing. If not careful, damage to the shaft or surrounding equipment can occur. An acetylene torch, for some the tool of choice to remove a mounted ball bearing, and referred to as the blue wrench because of the color of the flame, is used to cut through the housing and bearing for removal of the shaft. If not careful, damage to the shaft or surrounding equipment can occur. Not a recommended method for bearing removal, but when all else fails and frustration sets in, sometimes nothing is better than a really big hammer. The new Sealmaster ball bearing with patented time-saving axial groove on the inner ring on large bore can reduce total time required when it comes to changing a mounted ball bearing. This patented design eliminates the interference with the burr by utilizing axial grooves at set screw locations that run the length of the inner ring. We will now show you the removal of a bearing with the time-saving axial groove in the bore. To remove the new Sealmaster bearing with the time-saving axial groove, simply loosen or remove the set screws and pull the bearing off the shaft. It is really that simple. Let us see that again. Note: in the case of excessive fretting corrosion, a hammer and drift or bearing puller may be needed, but the bearing with the patented time-saving axial groove on the inner ring should reduce the shaft damage caused by the burr. Many methods exist when removing a mounted bearing from a shaft. The time-saving axial groove design is a real time saver. Time is a valuable commodity in plant operation. When a bearing needs to be replaced, either planned or unexpectedly, every minute of downtime can cost thousands of dollars. The time-saving axial groove can reduce your total downtime to change the bearing. Imagine, how much time can you save?